So we're back on again. Okay, now for the second stage, we're going to talk a little bit about bio-augmentation. So it's still considered one of the major techniques used in bioremediation. Now, in this case, bio-augmentation uses something a little bit different than bioventing. While bioventing uses indigenous bacteria, bio-augmentation uses a a very specific bacteria. I won't say whether it's indigenous or not, but they use very specific. Now, by meaning that is that scientists have already identified a certain strain of bacteria or maybe fungus that will do a much more better job than using the entire indigenous species in the soil. Now, once this microorganism has been identified, they will be propagated in the lab. That means scientists were going to go to the site, collect soil samples, and then isolate the important microorganism into its individual colony. So once that is done, each of these microorganism will be given enough nutrient, enough temperature, and also enough whatever that they require so that they will grow much bigger in colonies. So with that, this specific bacteria that has been propagated will be sent back to the site. You see, that is a major difference right there, isn't it? So you're only going to propagate a few bacteria strains that you know will do its job much better than the rest. So you put those bacteria, you enhance their colony. Of course, with that, they will going to enhance the bioremediation, and hence the name itself, bio-augmentation. Bio, of course, using biology. Augmentation means you make it bigger, in this case, yeah? You make the impact of the bioremediation much more bigger. So I think from the explanation that I've given just now, you have already explained the first and the second point. Now, it is quite safe to say majority of the remediation technique uses this one. Because in terms of cost and effectiveness, bio-augmentation far better than bioventing. Bioventing is like you do things blindly. You just put air inside and hope for the best. But bio-augmentation was certainly going to ensure effective bioremediation because you know what's going on inside and you just use that bacteria to do the job. Great. So like I said, it only select a specific microorganism to do the job. So just now I may have specifically named bacteria. Now it's not just bacteria. Sometimes fungus also is equally good. Not just fungus, any lah. But usually like in terms of bio-augmentation, usually two of these organisms comes in four lah. Bacteria or fungus. Yeast not that much lah. Most of them they are fungus. Okay, the concept is based on the fact that they are biological degradable solid within the wastewater. Biological treatment generally uses the use of intrinsic bacteria which are present in the... Okay, so I think these are the explanation that I have already presented to you, so I think I will skip to the next point. Okay, these are the elaboration, the justification why bio-augmentation is used instead of bioventing. So like I said to you just now, bioventing, not all bacteria can be used. Bio-augmentation, you select those bacteria, make them much more, make them bigger, make them bigger in terms of numbers and colonies, and put it back so that it will do the job effectively. So here it is, the application for bio-augmentation. And yeah, one more thing, bio-augmentation, what's good about it is that it will address a certain problem, which means that if you have one bacteria and you know that bacteria can solve the contamination of PCB, for example, you just send that bacteria and it will just go to attack PCB. So what happened to other components of the soil, like the nutrient level? Will it impact the nutrient level? Well, maybe, but the issue here is that if you send the right bacteria to do the right job of removing the intended contaminants, you will going to be able to solve that problem and not aggravate the problem by creating another. Now, because most of the time, when you send a non-native bacteria, if you send a non-native bacteria into the soil, most likely it will going to disrupt the ecology system of the soil. And you introduce a foreign species, it will going to have some sort of impact. However, if you have isolated, assuming that the scientists have done enough scientific evaluation of the bacteria, the impact will be greatly minimized because you know what that bacteria is capable of. So in bioaugmentation, prior to that, during isolation of the specific bacteria that's intended, enough study have been conducted to evaluate not just how good they are in remediating the bacteria, but also to assess its impact. What are the other effects, bad or good effects towards the soil, maybe to other soil organism? It will be evaluated, and from there, bioaugmentation not only enhance the bioremediation, it also much more better in terms of not to disrupt the entire ecological system already exists in the soil. Okay. But the good thing usually people are going to address like, okay, if you have bacteria A, it will solve the first problem. So if you have two problems, like for example, chlorinated solvent is mixed with nitrophenol. So this you have two contaminants in the soil. Then what do? You just use two bacteria and do the job. So perhaps you might not be able to mix two bacteria together and do the job, but who knows? Some of the bacteria may not going to compete each other. So yeah, you can do it. But what's the problem? If they compete, you can actually start with addressing the I mean the easiest one. Okay, so there might be some criteria for you to start using bacteria A or bacteria B. Who knows that? But you can actually have both, which means that you can start with bacteria A and followed by bacteria B. At the end of the day, you solve two problems. So the summary of this, the keyword to summarize the benefit of bioaugmentation is that it is very specific, and it will it will enable us to better manage the contamination in the soil because we know it works and we know how to deal with it. Yeah. Okay. So the procedure is a repeat of what I said earlier. So microbial inocular, you isolate it, you pick the best one, and you grow it. So once grown, you will put it back into the site. Now, in this case, this bioremediation is used in groundwater. Yeah, bioremediation also can be used for aqueous phase. Uh, but of course, you also need to like put air inside lah, yeah. Because bacteria is just like any other bacteria, they also require some ideal condition to live. Now, in this case, they will propagate. Propagate means they will grow. Propagate means they grow and double in size. So they will only propagate when the ideal condition is met, like enough moisture. Of course, like soil itself, at least in Malaysia, soil itself already have enough moisture, and then it just need enough nutrient, probably a little bit of air, suitable temperature, and then it will do its job lah. Yeah. So what are the benefits? Product attack both solid and soluble pollution. So this will work whether for soil or groundwater. And then the most important thing about bioremediation is that you will not have any residual pollutants. Residue means if you put substance A, it solve one problem, but at the same time, it will create another problem by its excretion. So bioremediation will not do that because what? The pollutants essentially is like the food of this microorganism. So which means that they just consume it, turn it into carbon dioxide and water. So with that, it leaves no byproduct and no secondary pollutant, as we say it. Yeah. And then waste will be converted into natural food for fish and invertebrates. Well, I would say this waste is probably the biomass of the microorganism, not carbon dioxide. Yeah, carbon dioxide will not be the food of the fish and invertebrates. Okay, now this one biosmudging is something very similar to bioventing, but here's the thing: biosmudging is again very similar to bioventing, but biosmudging is used for saturated zone. So earlier, bioventing, if you still remember, it will require unsaturated soil, must have air inside. If no air inside, it must be permeable enough so that air can be pumped inside. Biosmudging is a bit different because it works on saturated zone. And in this case, we in biosmudging technique, um, we'll deal with the problem now. Is what I can say. Now, biosmudging will going to work by retaining the unsaturated zone. So we assume that we accepted that the soil itself is very wet, no air can go inside. So what they do is that they will add more nutrient and also air, a mixture of these both. So in this case, I would say biosparging probably will going to require a little bit more energy than bioventing, because bioventing, you already have air permeable inside it. But here is that it will still pump in air with plus plus material, and that is your nutrient. So the similarity is that it was still going to use indigenous soil, similar to bioventing, but in this case, they will send more nutrients. They will send air. Most likely, this air and nutrient mixture, when they send it in, it will be in semi-liquid form or maybe aerosol form, because nutrient needs water to mix. And at the same time, they'll pump in high pressure air inside so that it will reach the unsaturated part of the soil. Okay, so similar to the others, biosparging uses bacteria, indigenous bacteria, uh, in the soil, which is saturated with water, and then hopefully they will do the degradation, biodegradation by using the existing bacteria. So similar to bioventing, it will also going to pump in air. So now this table listed the advantage and disadvantage as compared to bioventing, I believe. So here you can see that, wait, let me see, yeah. Okay, I would say this one is the yeah, this is the pros and cons. Pros and cons of biosparging. So let's go to the advantage first. So advantage is can use any available equipment. So in this way, I would say the equipment will be a mixer to mix your nutrient with water, and then also a pump, a high pressure pump that pumps air as well as the liquid into the soil. So this one, you just need to pump air and also water plus nutrient, which essentially is already the existing component in the soil. You probably don't disrupt too much of the entire ecosystem in the soil simply because it's already part of the component. Um, unless you over apply the nutrients. So yeah. So assuming lah, okay, assuming the I mean all the benefits come from optimum or suitable amount of nutrients given. Now, when treatment works, it will going to take 6 months to 2 years under favorable condition. So I know you probably heard 6 months, 6 months to 2 years. That's quite long. But in terms of bioremediation, I tell you, 6 months is considered fast, because usually bioremediation takes much more longer than that. I'm talking about 5 to 10 years. So yeah, this is under ideal condition. Usually it does not yeah. And then it's cost competitive, obviously, because why? What do you use? Energy to pump air. And then air, free. Water, virtually free. Well, you can get it for free if you use groundwater. And then nutrient. Nutrient is the only expensive material that you need to buy, apart from energy. So, in other words, quite cost competitive, quite cheap compared to other ways. It enhances effectiveness of air sparging for treatment for treating a wider range of petroleum hydrocarbons. Now, in this case, some of these biosparging, they will be subjected to any place where you have highly saturated soil. So it increased the accessibility of air or whatnot, because biospudging also use pump to pump more air inside. So I think this one is quite kind of obvious. You pump air and they get more air due to biospudging, similar to bioventing lah, but this one you are increasing more air in the saturated zone. Okay, next one requires no removal, treatment, storage. So I think this one is similar to any other in situ bioremediation technique. So I won't go into discuss. And the last point of advantage of biospudging, low air injection rates minimize potential need for vapor capture. Now, now the pressure required for this biospudging technique is very similar to bioventing, in which even though we say high pressure, what we meant is the pressure high enough so that atmospheric air can be introduced into the soil. Not that we want to like impose very high pressure like flush out, like not like vapor extraction, but this one to get more air inside, that's it. So it essentially not too high pressure, higher than the original pressure already exists in the soil, just enough to make air go inside. So these are the advantages, but to sum it up, the advantage, not just biospudging, bioventing and bioaugmentation as well, the advantage is quite similar, in which their number one advantage is they are cheap. That's why bioremediation is much more preferred. And number two, they are effective. They're effective because it works. I mean, at least results from the previous study and previous remediation project proves that bioremediation can work. Okay, now those are the good things. Two good things. What about the bad things? I mean, well, I won't say bad things, but a limitation, I would say. So the limitation of this bioremediation, let's see, can only be used in environments where air spudging is suitable. So here, the soil is not uniform, as we all know, because different place, different soil, and also depends on what are the history of land use, isn't it? So to deal with this uncertainty, you also need a little bit of knowledge to plan this biospudging technique. And not to say that it may not work because of this ununiform permeable soil. Because when you want to pump things inside, you want to get the nutrient, the air, and also the moisture, I mean the moisture that contains nutrient, into that place. But because of this not uniform permeable soil, you pump it in that place, it goes somewhere else. So that is a problem when you have ununiform permeable soil. You want to put it there, but it won't stay there. It will go somewhere else. Because you know that the soil movement, I mean the movement of nutrient, depends on gravity as well. So that is one thing lah. The limitation, I won't say it is some other. That's the limitation. The next one, some interaction among complex chemical, physical, and biological processes are not well understood. I think this is quite common because why? It use indigenous bacteria again. Indigenous, there's so many kind of bacteria. Which one works? Which one do not? And if it works, what happened to the so-called intended bacteria that will do the bioremediation job? So what I can say about the second point, the second disadvantage is that there is no certainty. There is no certainty that whatever that you do in biospudging will work. See the difference between bioaugmentation and biospudging? Biospudging is better than bioventing, but I would say the second point actually tells the limitation of biospudging as compared to bioaugmentation. Because as compared to bioaugmentation, you use but one bacteria, but in biospudging, you use several. You rely on the existing community of bacteria. So a lot can happen. You don't know whether it work or not, and you also don't know how much it will work. Yeah, so it's due to the uncertainty here. And for your information, in engineering, usually this work they will be done by engineers. Engineers hate uncertainty, for information, because if it's uncertain, if it lengthens the project, that means you need to pay more. That is not engineers want lah. Okay, the third one, lack of field and laboratory data to support design consideration. So this one, yeah, lack of study. Because like I said to you, bioaugmentation is the most preferred technique. So biosmudging, not many people use. Whether it's work or not, we cannot revise because there's not much of data, isn't it? Yeah. So that is the downside. Like biosmudging is not too popular as compared to bioaugmentation. And then the last point, potential for inducing migration of constituents. How does it happen? Remember, you need to pump foreign things inside. Whenever you pump, you introduce energy, movement inside the soil, moisture. Yeah, that might happen. So these are the so-called limitation of biosmudging as compared to the advantage of it. So I would say I will going to skip this part. Majority of them that I have explained and touched just now. So these are the key parameters to evaluate the suitability of biosmudging. Usually the consideration will be the soil structure, whether it's permeable or not. Then you also need to know what are the indigenous bacteria already inside. So these are the consideration lah, yeah. What are the constituents or the site characteristic that you need to consider before biosmudging can be done?